How are you, my friends? This is another lecture in Algebra course, lecture 25 about inequalities. In this video, we will study 4 types of inequalities. The linear, you can see type 1, the compound type 2, polynomial type 3, and rational type number 4. Just quick idea here about inequalities. We have, as I mentioned, 4 types of the inequalities. With these colors here, we can have less than or equal, greater than or equal. Just a little difference here we have to know. If we have an equation, a linear equation like x power 1, then there is one solution in the graph. It will be 1 point on the number line. But if we have inequality, less than or greater than, we have the answer as an interval. So x less than or equal 3 means from minus infinity to 3 closed. That's the main difference between equation, inequality. This is a review from lecture number 4 in the algebra course about intervals. We have closed interval, we have open interval, as you know. We have half open or half closed intervals. We should be able to draw the closed half open. The closed, we put a closed circle, which means the point is included, the number is included. If it is open, we make it open like this. At infinity or minus infinity, always open. And then we can have closed and open like this, from 6 closed until 7 open. That's the interval. Now, some rules of inequalities, very simple rules. We'll go quickly here. Addition property, we can add on both sides the same number of the inequality. We can subtract the same number from both sides. Inequalities can be added if a less than or equal to b and c less than or equal to d. Then a plus c less than or equal to b plus d. You can add them. Inequality is transitive. If a less than or equal to b and b less than or equal to c, then a less than or equal to c. Easy to understand. Now, if you multiply inequality by a number, this number can be positive or negative. If it is positive, nothing will be changed. If it is negative, we have to switch or change the sign of inequality. Let's look here. Minus 7 less than minus 2. Let's multiply by minus 1. So this becomes 7. We should have greater. So you have to switch it. Greater than 2. Same thing if we divide. So if we divide or multiply inequality by negative number, switch the sign. You have to remember that. Let's go to type number 1 quickly. Here, let's go to the example first. 2x minus 1 less than or equal to 19. Take 1 on the other side, becomes 20. Divide by 2, x less than or equal to 10. Equal means closed. But infinity, minus infinity, plus infinity, always open. So what is x less than or equal to 10? It starts from minus infinity until 10 closed. These are 3 more examples. Easy linear. Linear means the degree, the x power is 1. So ax plus b can be greater than, less than, greater than or equal, less than or equal. All these symbols can be in the inequality. Let's take 2 more examples. Example 1 has parts A and B. The first one you can see no fractions. Here we have some fractions. I will tell you what to do. We have mentioned before. Let's see the first one. Just expand here. Distribute minus 3, distribute the 4, simplify. Easy, you can try it. And then this is minus 6, minus 3x, minus 5x. On the other side, we have 4x minus 8 plus 1. Bring everything on one side with the x. The numbers on the other side. See what we got here. Minus 12x greater than or equal to minus 1. Divide by minus 12 and change the sign. Just remember, please. So x will be less than, it was greater than here, less than or equal 1 over 12. Now, if this minus 1 here, plus 1, this becomes here minus. We know that. So let's draw now x less than or equal to 1 over 12. So we start from minus infinity until this number closed. That's the answer here. This is the interval. Now, can you try the second one, please? I advise you here, take a minute, pause the video, try it here. We can see in the denominator 6, 2, and 3. So the LCD is 6. Just remember, please, before you do it, that if the LCD is constant, see like 2, 3, 5, 10, 7, 8, no x, no variable, it's easy, you can do it. If it has a variable, you have to wait until a few minutes. Yes, in this video, I will tell you what to do. Now, the second one here, yes, the LCD is 6. So directly I multiply by 6 the first term, multiply the second one by 6, multiply the third one by 6, and be careful. Remember, when you multiply by the LCD, you will have no fractions at all. If you have any fraction here in this line, that means something wrong in the LCD or something wrong in the multiplication. So go and check, please. So we have 7x minus 6, 6 will be cancelled. 6 over 2, 3, we have 3 in the bracket. 6 divided by 3 is 2. And simplify until you get 6x greater than 14. See, the coefficient here, 6, is not minus. So we divide by 6, but we don't change the sign. Greater than stays greater than 7 over 3. So open because there is no equal here. So from 7 over 3 until infinity, this is the answer. I put here open just to remind you. Type number 2, compound. Compound when we have two inequalities together. It can be less than or equal, less than, greater than. Any two inequalities, they can be like this question here. Example here, let's solve this. Minus 13 less than or equal to 2x minus 5 less than or equal, both closed here, 9. Now we have to remove this minus 5. So I add 5 on each side. We have 3 sides here. See, 5, 5, 5. If you have minus 7, you add 7, 7, 7. If you have plus 17, you subtract minus 17, minus 17, minus 17. Now here we divide by 2. So x between now, see the final solution between minus 4 closed to 7 closed. These are the values of the x. Let's take more interesting example on compound. Look at this, please. Nice question. Minus 1 over 3 less than or equal x minus 1 over 2 plus x over 3 less than 1. Clearly here we can see the LCD is 6. So we multiply this by 6, this by 6, this by 6, and this one also by 6. Let's solve it, graph it, and write the answer in interval. You want to try it, please? Okay, let's wait. And then it's time to see the solution. So let's multiply by 6. Remember here, you will have no fractions whatsoever after you multiply by the LCD. 6 times minus 1 over 3 is minus 2. 6 times the first term here, see 6 over 2, 3x minus 3, that one here. 6 over 3, 2 is 2x there. 6 times 1, don't forget 6. Now simplify, we have compound. Let's add 3, add 3, add 3. So now we have here divide by 5. Sometimes we have a minus there. We will see later. You changed both signs. Remember, if the coefficient here 5 is minus 5 or minus 2 or minus 1 or minus 10, change all the signs. Now this is positive, we don't change it. So look here, closed 1 over 5 until 9 over 5 open. All this interval is the solution. Between 1 over 5 closed, 9 over 5 open. Type number 3 is the most interesting and important maybe, polynomial inequalities. Polynomial like x squared, x cubed, x power 4, etc., etc., etc. This is so much important because it will be the same idea, same method for rational also. So the steps are, we move all the terms to the left side. Remember here, 0 should be on the right side. I will give you so many examples now. We factor the polynomial on the left, you know, like because 0 on the right. We divide the number line, we use number line. We divide it by using the zeros. And then we choose a test point from each interval. And then we call this table of signs. Let's see this example. I will come back to these steps maybe, 1, 2, 3, 4, 5. You will understand them. Example 3, I said here the most important. It's not the most difficult. Remember, we have more difficult than this, but this is the most important, which means if you understand this, example 3, just example 3, you will be able to do all the polynomials and the rationals, but you have to be careful. Let's go. X squared plus x less than 6. We need the solution, the x values. See, we have to move. Remember here, number 1, move all terms to left side. So I have to move the 6. Whatever the reason, I have to take all this on one side. Let me show you. So I take 6 on that side, then I factor it easily, usually easily. And then I find the zeros. The zeros, the number that will make each factor 0. I use them now. These are not the solution. I use them. So this is 2. This is minus 3. Put it there. 2 and minus 3. Put it on the number line. It can be 2 numbers, 3 numbers, 4 numbers, 5 numbers, whatever, whatever. Put all the zeros there. Now take the factors here. It can be simple, medium, difficult, very difficult question. Put here on the left side all the factors. Now look at number 4 here. Choose a test point from each interval. So let's choose a test point. See, from minus infinity to minus 3, we have minus 3 to 2. 2 to infinity. In this question, because we have 2 zeros, we have 3 possible intervals. Again, minus infinity to minus 3. Minus 3 to 2. 2 to infinity. Why we have 3? Because we have 2 zeros. So you can understand now, if we have 3 zeros, then we have 4 possibilities here. If we have 5 zeros, there are 6 possibilities. We have to test each one. How? Take a number from minus infinity to minus 3. Let me take just a number. Don't take a number close to minus 3, please. Let's take minus 10. Replace it in the x here. Minus 10 minus 2 is negative. I'll just take the sign. Minus 10, same number, plus 3, that's a minus. See here between minus 3 and 2, let me take 0. Nice number 0. You can take 1 if you like. So minus and plus. From 2 to infinity, you can take 20. So that's plus and plus. See here we have multiplication. So you multiply negative by negative, that's positive. We call it result. Negative positive, that's negative. Positive positive, if you multiply, you get positive. Now what do we need in our question? Less than 0. See this one here? Less than 0 means choose the minus and open. Open y? No equal. So where is the negative here? You see the result. Just by using your eyes, you can see the solution from minus 3 to 2 open. Finished. Easy. Now you will say very easy, yeah. But there are tricks in these questions, but the same idea. Let's take a few more, please. And you can review that. Look here. Solve the polynomial. X cubed, x squared. We have x minus 1 squared and the other number. Remember step 1. Step 1, what do we do? Take everything on the left. Never change this step. Now, as I mentioned in step number 1, we move all the terms to the left side. So here we expand x minus 1 squared by the formula, x squared minus 2x plus 1, and then take minus 2 plus x greater than or equal to 0. Simplify all this, we will get this inequality here, x cubed plus 2x squared minus 3x. You can check the numbers, please. And then greater than 0, we have to factor it. See, since we have 0 on the right side, we start factoring x common factor. Then we have a trinomial, x minus 1, x plus 3. Remember, I find the zeros. See, when I said example 3 is the most important, same idea. It can be harder, bigger, more zeros, bigger table. but same idea. So the zeros here are 0, 1, and -3. Remember, these are not the solution. These are the zeros. They will be placed on the number line, -3, 0, and 1, you see. Now we divide this number line into -infinity to -3, -3 to 0, 0 to 1, 1 to infinity. As I told you, 4 intervals because we have 3 zeros. Then I put now all the factors here. X, it can be squared, cube, whatever. X, x minus 1, x plus 3. Then I take a test point, number. Just choose a number, the number you like. Don't choose a number very close here. Take a number far, -7, -50, -100, -10. Replace it in the x, you will get all negative. Take a number between -3 and 0. Let's take -1 is okay. So there comes minus, minus, and plus. Between 0 and 1, take half. Just put here half. Half -1 is negative, half plus 3 is positive. And then any number after 1, it will make it all positive. Now you multiply everything. 3 minuses will give you minus. 2 minuses and plus will give you plus, etc. So we choose the solution. See, the last inequality here, greater than or equal. So take the positive from the table, positive here, positive there. Why? Greater than or equal, make it closed. So the solution will be -3 closed to 0 closed, union, 1 closed, infinity always open. That's a nice question. Let's see more. Example 5, exam type. So as in the exam, not difficult. If the solution set of the inequality here, all this, you see this one, is given by the interval mn, 2 numbers there. Find the value of m times n. It's very important now. You can pause the video, try it yourself. Now I can help you here. You multiply, bring everything on the left, 0 on the right, factor it, table of sign, choose the solution, then multiply m and n. As I said, I think you will get this one, x squared minus 3x minus 4 less than 0. Small table because we have 2 zeros there, 4 and -1. Choose the negative. Why negative? Because less than 0 here. So -1 to 4. This is m and n. When you multiply them, you get -4. Now, what will happen if the expression cannot be factored? All of these, we call them special cases. So if the discriminant is not perfect, so find discriminant, D, capital D is B squared minus 4AC. So you will find either discriminant is positive or negative. I will show you another slide. If it is 0, what will happen? So if discriminant is positive, you make table of signs. But the zeros are irrational, not easy numbers. Maybe you need a calculator. See reading example number 1. Only for reading, I will show you after a minute. If discriminant is negative, minus, it's like -7, -10, -12, -50. This is a special case. We will see also reading example 2, then I will explain it. Just to mention here, if the discriminant is negative, you have to use this rule here. If the leading coefficient is positive, then the whole expression is positive. Just remember that. If the leading coefficient is negative, then the whole expression is negative. I will show you more than one example. This is reading example number 1. Suppose we need to solve this. Usually put everything on the left side, 0. Factor it. We cannot factor. Directly we find discriminant here. See, discriminant is 12. You see that one here? Discriminant positive. That means there are zeros. If you simplify this, you get -1 plus or minus square root of 3. The zeros are difficult, but you can put them here. You see, you need a calculator. -1 plus square root of 3 is 0.7. -1 minus square root of 3 minus 2.7. Now you can choose any number there, -10, 0 here, 10. And then you can get the answer. But if it is more difficult, you need a calculator. That's why I call it reading example. Now let's look at reading example number 2, special cases. Solve the polynomial inequalities. when you look at inequalities like this, if you cannot factor, then we have to find the discriminant. Here A is positive 3 and A here is negative minus 3. You will see what happens. Now, if you cannot factor, you find the discriminant, b squared minus 4ac. So minus 47, so the discriminant is negative. If the discriminant is negative, you look at the leading coefficient, LC. This is the leading coefficient here, positive 3. So that means the whole expression is positive and greater than 0, yes, positive greater than 0. So the final answer, all real numbers. So when you have inequality like this, quadratic, which is power 2, if the leading coefficient is positive, then the whole graph is positive. And we are solving for x greater than 0, which is correct and okay. Now let's look at the second example here. B part, minus 3x squared plus 2x minus 5. Let's find, we cannot factor this. Let's find the discriminant. So b squared minus 4ac. Discriminant is negative minus 56. So discriminant is negative. We look at the leading coefficient. See, the leading coefficient here is a less than 0. That's a minus 3. So the whole graph is below the x. But in our question here, we said solve this greater than 0. So the expression is negative. You see, greater than 0, no. Negative, greater than 0, no. So no solution here. There is no value for the x that will satisfy it. Now what will happen? This is a reading example number 3. If the discriminant is equal to 0, let's look at this example here that has 4 parts. X squared minus 10x plus 25. Try to find the discriminant minus 10 squared b squared minus 4ac, which is 100 minus 100 is 0. So these also special cases. Just to remind you down here that x squared minus 10x plus 25, you can make it as x minus 5 all squared. So this will be the graph here. See, squared, discriminant is equal to 0. So the parabola here is tangent to the x-axis at 5. So if we have the same expression greater than or equal to 0, yes, this is positive because the leading coefficient here is 1. If we have this is only greater than 0, all real numbers except the 5. 5 is there. 5 will make it 0. If we have less than or equal to 0, this is the only number 5 because 5 is less than or equal to 5. And this is negative. This is all positive because this is the leading coefficient here is positive. So that's positive. Less than 0? No, it is not. So that means no solution for this one. These are all special cases. Now, if you go to type number 4, rational inequalities, good news here that we have to use the same table of signs as the polynomial. Move all terms to left side. Remember that. Move all terms to left side. 0 on the right. Then you combine the fractions to find the zeros and make a table. Let's see. Example 6 has 2 parts, A and B. The difference between A and B is this. A is ready because we have 0 on the right side. And this is not ready because we have 2 there. That's an important question. So if there is 2 here, we cannot cross multiply in inequalities. So we have to bring the 2 there and combine the fraction. Let's do the first one, which is easy. So if 0 on the right side, directly we go to make a table. So let's look at the zeros now. Remember, the zeros are not the solutions. Minus 7 and 8. So on the table here, I put minus 7 and 8. And then I put all the factors, x plus 7, x minus 8. I take a test point as we did before. Any number there, you can take minus 20, minus 50, minus 39, minus 10. And then take a number between minus 7 and 8. let's see, maybe a 0 or 1 or 2 or 3. So it will be positive and negative. Take a number greater than 10, maybe 12, maybe 50, maybe 100. So this becomes positive and positive. When you divide negative by negative, that's positive. Positive by negative, it's negative, and this is positive. Now look here, greater than 0. Greater than 0 means choose the plus from the table, this one and this one, and open. I have said before, why it's open? Because this is not equal. See, there is no equal here. We make it just open. So minus infinity to minus 7 union 8 to infinity. That's the easy question because we call it ready. Now let's see the second one. See, the second one is more difficult. There is a 2 there. We need to take it on the other side. See what will happen here. Now, before we go to B part, golden advice. In general, never multiply an inequality by LCD if any denominator contains a variable, like this one here. See, if you try to cross multiply, that's completely wrong. Instead, you have to take 2 to the other side and see the next slide. So this is correct here. And then you have to add or subtract. See, minus, we subtract. If there is a plus here, we add. Now the LCD, yes, we can if the LCD is constant, like 6 or 10 or 50 or 20 or 100, whatever. Okay, I think this is clear now. Now let's go. This is not ready. So I take 2 on the other side. You see, we have to do that. That's the only way. Combine fractions on left. This one, you have to add them here. Even there is an LCD here, but I said do not multiply. I will say this again. You can combine, you need LCD, but do not multiply by the LCD. Do not. So this one here, the LCD x plus 4 up and down, it will be x plus 4 here, minus 2x minus 8. So the answer there, minus x minus 6 divided by x plus 4. Now ready, find the zeros here. Now from the last slide, we see minus x minus 6 over x plus 4 less than or equal to 0. This is now ready, so we make the table. So the zeros that are minus 6 and minus 4, be careful, both are negative, no problem. Just make the table here, put all the factors, minus x minus 6, x plus 4, choose a number, as I said, from the interval, minus infinity to minus 6, any number you like, minus, let's say 12 is okay. So it will be plus and minus. Between minus 6 and minus 4, we can take, let's say, minus 5. This becomes minus and minus. Any number greater than minus 4 until infinity, take 7, take 50. It will be minus and plus. Now, less than or equal, we choose the minus. See, this is a minus and this is a minus. There's an equal here, less than or equal, or this one also less than or equal, same as that one. We choose the negative and closed. Now, why we have this one open? Remember here, remove the zeros of the denominator from the solution. What will make the denominator 0 here, or the 0 here is the same here, x plus 4. So minus 4 will be in the denominator. So this is like a check. After you find the solution, if it is open all, that means it's okay. If it is closed, you check. See, minus 4, we cannot take it in the solution because it will make the denominator 0. So we make it open. Just remember to remove all the zeros of the denominator from the solution. Let's see an exam type here. Solve the rational inequality 2 plus x divided by 2 minus x. That's not an easy question. Greater than or equal to 3 over 1 minus x minus 1. Now, once you look at the question like this, you have to remember the golden advice. What is the golden advice? Never multiply both sides by LCD if you have a variable in the LCD. If it is constant, you can do that. Now, what else we can do? Move everything on the left. See this one here? That's the given. Move it on the left, minus 3, 1 minus x, plus 1, greater than 0. Now combine on the left. Find the LCD, but do not multiply. Again, you see this golden advice? Never multiply inequality by LCD if it contains any variable. So instead, we take all this, see all this, rational expressions, and we combine the fraction. So we use the LCD, 2 minus x, 1 minus x. So the first one we multiplied by 1 minus x up and down. The second one we multiply by 2 minus x up and down. And the one here we multiply by the LCD. Because when we simplify everything on the left, you see greater than 0, on the left, we simplify all this. X squared will be cancelled, minus 3x will be cancelled. So minus x minus 2, 2 minus x, 1 plus 1 minus x. You can check these, please. Now, when you have all this ready, find the zeros, make the table. So the zeros are minus 2, 2, and 1. See, this will make it 0, 1. This will make it 0, 2. This will make it 0, minus 2. Just make a big table. Minus 2, 1, and 2. And then put all the factors as we said many times. Minus x minus 2, 2 minus x, 1 minus x. Choose a number. You can choose here minus 10 between minus 2 and 1. You can choose 0 between 1 and 2. You can choose 1.5, and here you can use 7 or 10. Now remember, we need greater than 0. Greater than 0, we choose the plus. See the plus here, minus infinity to minus 2. That's a plus. Another plus here, 1 to 2. Remember here, it should be all closed because we have equal. But remember, remove 1 and 2. Why 1 and 2? Each one will make the denominator 0 here. See, 1 will make it 0, 2 will make it 0. So we remove it, we make it open, open. Minus 2 is okay because minus 2 will make the numerator 0. If you put here minus 2, it will be 0. 0 greater than or equal to 0, yes. But in the denominator, we cannot accept 0. Let's look now at important remarks in inequalities. I have prepared here 6 remarks. You can use them anytime you like. When you see an inequality, decide first the type. It might be linear, it might be polynomial, compound, rational. Then you can think of the method or the way that you have to do. Change the sign of inequality if needed. Remember, changing the sign when you divide by minus or multiply by minus. If LCD is not constant, it contains a variable, then never multiply the inequality on both sides by the LCD. Table of signs, you can use make table of signs if you have a polynomial, x squared or more, x cubed, x power 4, or rational inequality. Split if compound inequality is not linear. You have a compound and it is not linear. We will see one question after a minute. And then the last remark or advice, remove the zeros of the denominator from the solution. Now we have reached the old exams questions or practice questions. So I prepared one of them here. This is a linear, that's easy. Second one is a compound. But see, the compound here is a linear because x has power 1. So we don't have to split. Remember this, you don't have to split here. This one is a polynomial. You have to think, well, how do you do that? Number 3, you have to make a factoring, table, etc. This one, read it please. Find the values of decay for which the given equation has non-real complex solution. This is a quadratic equation. Quadratic equation. Each one has complex or non-real solution. Find the values of k. You have to work with discriminant. Number 5, look here. The solution set of the inequality 0 less than x squared minus 4 less than or equal to 5. What is this now? Compound, and it's a polynomial or quadratic. So this is not linear. So we go now here back to split. See, split if the compound inequality is not linear. If it is linear, we know how to do it. There are many examples there. But this one is not linear, so you have to split. It means take this one, 0 less than x squared minus 4, and take the other x squared minus 4 less than 5. So you will have two inequalities. You do each one with table of signs, then you find the intersection. And these are the answers. One of them is correct. The rational, we have done the rational. Remember, 0 should be on the right. Number 6. Another rational here, less something here, less than 1. You have to make it 0. And then number 8 also is rational, 1 minus 4 over x less than minus 1 over x minus 1. This is not easy because there is a little trick inside the question. And number 9, it's already factored, but I will leave the idea for you to think. How can you make a big table? Think of the idea, then you will check the solution. So look at number 9 here. I put the same question, greater than or equal to 0. After you do question 9, please, see what will happen if we change greater than or equal to only greater than. There is no equal. The answer, I'm telling you, the answer will be different. Try to figure out how the answer will look like. Now, here I prepared all the answers for the questions from 1 to 9 only. Just the final answer. Now, if you need the complete solutions of all these 9 questions, please, you can see the video on all the exams questions, inequalities, polynomials, and rationals. Thank you for watching. If you like the video, you can subscribe and share it with your friends. And I hope I can see you in another video with another topic. Just to remind you, this is lecture 25, inequalities. Thank you very much.